Assalamu alaikum everyone. I am Mehnaz Akhtar, lecturer, Department of Physics, Milestone College. Today I am here to take the online class. Because of the coronavirus, we are unable to take the classes in the classroom. Coronavirus is creating different types of fatal diseases in our body. So I have to say to keep the social distance and wash your hands after some times. By doing those two things, we are able to prevent this virus from our body. So we have to do these things perfectly. Now I am here to take the online class. So let's start today's class. Here we will do another math which is came in Position Board 2016. Let's have a look what the statement and the stream says. The potential difference of electricity in Rakib's house is 220 volt, that is given in the house, but they need 660 volt for their fridge, which is requirement. For this, they built a transformer which contains 200 loop in its primary coil. The number of turns for the primary coil is 200 given. So in the question it says what is electromagnetic induction. We have to find out the definition here. The change in the magnetic field produces an electromotive force on the current in a circuit kept the changes magnetic field. This process is called electromagnetic induction. In the next question it is said that how can we increase the induced current? How can we increase the induced current? There are lots of processes are there that the way we can change the induced current by increasing the number of turns in the circuit. We can also increase it, and by using strong magnet and changing the magnetic field. Those are the process to increasing the induced current. So in number C it is said that calculate the number of turns of secondary coil at Rakib's transformer. So we have to find out the number of turns for the secondary coil in Rakib's house. To do so, we have to write the formula here, and the formula is so we are writing the formula at first here, and the formula says that Vp by Vs equals to Np divided by Ns. We have to find out the number of turns for the secondary coil, and for this reason we have to write Ns in the left. So Ns equals to Vs Np divided by Vp. Now putting all those values here, Vs is 660 given in the stem. Number of turns for the primary coil, it is given here 200 look, so I am writing here 200, and Vp is 220, so 220. By putting all those values, we get the number of turns for the secondary coil is 600, which is the required answer here. Now we have the remarks question here, and the question says mathematically show that the current of the primary coil is 2.5 times of current of the secondary coil. So we have to find out the current for both the coils, and to do so we have to write the formula at first. So we know Vp by Vs equals to Is by Ip. So if I am writing Is equals to, then the answer will be Vp by Vs into Ip. So in the statement we know that for the secondary coil it is 660 potential is given, that means here, and for primary coil it is 220 volt. So it is 220. Now current is not given here, so I am putting the current in that way. So we can find these things here, 1/3 into Ip, Is equals to, or we can write Ip is 3 times of Is. So the question says mathematically show that the current of the primary coil's current, that means Ip, is 2.5 times of the current of the secondary coil. So it is not 2.5 times, it is 3 times. That means the statement is wrong, that the statement is not correct. So in the statement we have that the current for the primary coil is 3 times of the current of the secondary coil, which is the conclusion. We have to Write the conclusion at the end of the answer. So I'm writing here. So current for the primary coil is 3 times of the current of the secondary coil. I think you all understand this math perfectly. If you have any type of problem for understanding this maths or anything, then you can talk with me or your subject teacher. Thank you very much for being with me in the full lecture. Chapter 2017. Here we can see that there are two figures are available, figure A and figure B. In figure A, there is a transformer is available where number of turns for primary coil is given 100 and number of turns for secondary coil is given 180. Potential for the primary coil is 12 volt and potential for the secondary coil is X. That means somewhere we have to find out this. In figure B, there are 3 bulbs are available, 40 watt, 60 watt, 100 watt, and their resistance are also available. Here you can see that the question says write elaboration of ECG. This question is not actually from this chapter, but in physics we can see that A and B marks question. That means the theory part could be mixed in with any chapter. So we should be prepared for that. So here ECG is electrocardiogram. Don't forget to read the spelling perfectly, because if the spelling is incorrect, then the answer is also incorrect. Let's have a look at the B marks question. In B marks question it is said that why is electric current reduced for transmission of electricity over long distance? So in the transmission of electricity over long distance, there is system loss and also heat is produced. As more the electricity is moving over long distance, more the heat is produced here. Somewhere the heat is moving in the surrounding, in the air, and when more heat is produced, when the electricity is flow over there, then what's happened? Also resistance is increased as well. That's why when the electric current is reduced in the transmission of electricity over long distance. The C marks question says that calculate the value of X from the figure A. In the figure A we have the value of X. We have to find out the value of X here. So to find out the value of X, we will write the data at first. So let's have a look what the data says. Here potential for primary coil Vp is 12 volt, which is available here. Number of turns for primary coil is also available here, Np, which is 100. Number of turns for secondary coil, Ns, is there, 180, and we have to find out the potential for secondary coil, which is Vs equals to what? So we have to write the formulas at first. So we know Vp by Vs equals to Np by Ns. As we have to find out Vs, so I'm keeping this in the left side. So Vp divided by Np. I'm putting all those values here. Ns is 100 and Vp is 12 divided by 180, and the answer came 21.6 volt. So this is the required answer in the question, because the question asking the value of X, that means the potential for the secondary coil, and the potential for the secondary coil is 21.6 volt. Now we will do the D marks question here. In D marks question it is said that if all the bulbs run at a time with the obtained value of X in the figure B, is it possible to get the maximum light? That means the value of X, 21.6, that we get from the C marks question, if it is used in this circuit, then the bulbs will glow or the bulbs will get the maximum light or not. So we have to find out the power for each of the bulbs. So for that we have to write the formula and data. At first we will write the data. So here for Beamer's question, here potential V equals to 21.6, which is we get from the Beamer's question. Resistance for first bulb R1 is 11.664, which is given in the stain. Resistance for second bulb is R2, which is also available here, 7.776 ohm. And resistance for third bulb, that is R3, is 4.664 ohm. So we will find out the power here, and to find out power we have to write the bulb's power each here. So for first bulb, P1 equals to P square by R1, 21.6 of whole square divided by 11.664, and it is 40 watt. For second bulb, P2 is P square by R2, 21.6 of whole square divided by 7.776, 60 watt. For third bulb, P3 is equal to P square by R3, 21.6 of whole square divided by 4.664, that is 100 watt. So 40 watt, 60 watt and 100 watt, which is available in the question also, and you also get these things from the calculation. So we can say that if we connected all the bulbs together at a time, then they must be blue or they must get the maximum light. So you have to conclude it, because without conclusion 1 mark should be deducted from the answer script. So we will write here, if all the bulbs are connected at a time, then it is possible to get the maximum light. So the question is asking that it is possible or not. So we are saying that yes, it is possible, but we have to write in that way. If all the bulbs are connected at a time, then it is possible to get the maximum light. So in this question we have to explain that it is possible or not, and we explain that yes, it is possible.